So with this section, we are now going to be solving absolute value inequalities. An absolute value inequality is an inequality that contains an absolute value expression. For example, we have here the absolute value of x is less than 2 and the absolute value of x is greater than 2. You are going to be seeing absolute value bars again. Instead of seeing absolute value bars with equal signs, though, you're going to be seeing absolute value bars with inequality symbols. To solve absolute value inequalities, you'd solve them the same way you solve absolute value equations. So if you remember what we did, the first step is you isolate the absolute value expression. So you basically get rid of any of the numbers being added, subtracted, multiplied, or divided on the outside. Then you rewrite the absolute value inequality as two inequalities and solve them separately, and then you would graph them on the number line. So letter A says the absolute value of x is less than 2. This means that the distance between x and 0 is less than 2 units away. So when we are looking at these types of inequalities, it's actually very confusing sometimes when they're this easy what to do. Every absolute value inequality is going to be split up into two separate inequalities. You drop the absolute value bars, and the first one will look identically to this without the absolute value bar. So the first one is x is less than 2. Notice all I did here was I got rid of these straight vertical little lines around the x, and I wrote everything else the way that it is. X is less than 2. When you're solving absolute value inequalities, the first one looks exactly like the problem without the absolute value bars, but the second one, you drop the absolute value bars again, but you flip the sign and you change the number to become its opposite. So this is where it gets confusing. The second inequality, you flip the sign and you flip the number to be its opposite. That's how you would set up the problems. Then you would put both of these endpoints on your graph, -2 and +2, and you would graph them. Anything less than 2 would be an open circle to the left. Anything greater than -2 would be an open circle to the right. So the absolute value inequality, which is the absolute value of x is less than 2, the answers would look like this here on this graph. The first thing you do is isolate the absolute value expression. You split it up into two inequalities, then you graph them. Letter B gets a little bit more tricky since now we have some numbers and attached to it and not just like the absolute value of x. Now we have the absolute value of x plus 7 is less than or equal to 2. To solve absolute value inequalities, you have to rewrite these as two separate inequalities and solve them. Absolute value inequalities are just like compound inequalities in that you have two separate inequalities to solve. The first one, you drop the absolute value bars and you write the problem exactly like what it looks like without the absolute value bars. You see where I got that? You write the x plus 7, which is on the inside, and then less than or equal to 2. That is one of the inequalities you solve. The second one is going to be a little bit weird, though. You still write x plus 7, but two things happen. You have to flip the sign, and you have to flip the number, basically, to be negative. So it's going to be x plus 7, not less than or equal to, but greater than or equal to, and not +2, but -2. So, step 1, you write the two inequalities out. The first one looks just like the problem without the absolute value bars. The second one looks just like the problem without the absolute value bars, but you will then have to flip the sign to be the opposite and flip the number to be negative. Once you have your two inequalities, then you would solve them. For both of these, the only thing you have to do is subtract 7 from both sides. 2 minus 7 is -5, so this endpoint will be -5 here. Subtracting 7 here, -2 minus 7 is -9. So our two endpoints are -5 and -9. -9 is smaller than -5, so I would need that first, and then -5 could be here. To graph this, anything less than or equal to -5 would be a closed circle at -5. Anything less than it would be to the left, Anything greater than or equal to negative 9 would be a closed circle at negative 9. Anything greater than or equal to it would be to the right. All right, a couple more examples. Letter C. The first thing we have to do is write these inequalities separately. The first step that you take is you write the inequality just like you see it. You just drop the absolute value bars around the 2w minus 1. So the first inequality you have is going to be 2w minus 1 is less than or equal to 11. That's the first one. The second one is a little bit more difficult. You still write 2w minus 1, but you have to do two things. You have to flip the sign to be the opposite and flip the number to be negative. So it's now going to be greater than or equal to negative 11. Once you memorize those steps and once you have this set up, it should be easy because then you just solve these inequalities separately. And at this point in the game, we should have no problem solving two-step inequalities. Adding 1 to both sides, I get 2w is less than or equal to 12. Divide by 2. One of my endpoints is 6. Anything less than or equal to 6. And then the opposite, same two steps, adding 1 to both sides, I get 2w is greater than or equal to negative 11 plus 1 is negative 10. Dividing by 2, I get w is greater than or equal to negative 5. I did not have to flip the sign for that second one because I did not divide by a negative. I divided by a positive 2. So the two endpoints that I need on my graph are negative 5 and 6. Anything less than or equal to 6 would be a closed circle at 6. Anything less than it would be to the left. Anything greater than or equal to negative 5 would be a closed circle at negative 5. Anything to the right. So the answer would look like this. Now notice, the graph of these looks just like your graphs of compound inequalities. Absolute value inequalities are just like compound inequalities in that you have two endpoints, and the answers are either between those two endpoints or on the outside of those two endpoints. Once we get to the two examples on the next page, we will see that sometimes the answers are not going to always just be between. The next two examples, the answers are going to be on the outside of two endpoints. So if we look at letter D here, this says the absolute value of x is greater than 2. This means the distance between x and 0 is greater than 2 units. To solve something like this, to graph it and have your two answers, you separate this into two separate inequalities. You drop the absolute value bars, and the first one will say x is greater than 2. It's exactly like the original problem. You just get rid of the absolute value bars. The second one, two things happen. You still write the x, but then you have to flip the sign to be the opposite and flip the number to be negative. So the two endpoints you have are negative 2 and positive 2. Drawing these on your graph separately, anything greater than 2 would be an open circle at 2, anything to the right. Anything less than negative 2 would be an open circle at negative 2, anything to the left. So the graph of this inequality would look like an OR compound inequality because the answers are going to both directions outside of the numbers, not in between them. And actually, anytime you have an inequality that starts like this and has a greater than or a greater than or equal to symbol, the answers will always be on the outside. And vice versa, if it's less than or equal to, the answers will be on the inside. The last one we're going to do together before you're going to try a few on your own is letter E. Letter E says solve the absolute value of x minus 1 is greater than or equal to 5. The first thing you have to do is separate these into two separate inequalities. The first inequality looks identical to this one, just take away the absolute value bars. That's x minus 1 is greater than or equal to 5. The second one looks kind of the same, but opposite. You still write the x minus 1. You never change that stuff on the inside. That will always stay the same. But then you have to flip the sign to be the opposite. The opposite of greater than or equal to is less than or equal to. And you flip the 5 to become a negative 5. Once you have your two inequalities that you can solve, now the easy part is just solving them as normal. These you would just add 1 to both sides. 5 plus 1 is 6. Negative 5 plus 1 is negative 4. So the two endpoints I have are 6 and negative 4. I'll put those on the graph. Anything greater than or equal to 6 would be a closed circle at 6. Answers to the right. Anything less than or equal to negative 4 would be closed circle at negative 4. Answers are to the left. So, recap. To solve absolute value inequalities, the first thing you do is drop the absolute value bars. Alright? And then you solve two separate inequalities. The first thing that you do is you solve the first one exactly the way that it is. So the first one looks identical to the problem, just dropping the absolute value bars. The second one, you flip the sign and flip the number. Once you solve the two inequalities, then you would just graph as normal. So what I want you to try then is numbers 1 and 2. Actually, just try number 1. Try number 1, and then I'm going to catch up with you in like a couple minutes, and then we're going to do number 2 together because number 2 is really hard. So try number 1 in like 3 minutes. I'm going to stop you. We'll go over the answer, and then we're going to do number 2 together.